All right, and we're going to wrap up our very quick first unit here of second semester with our fourth lesson in Unit 5 here on page 15, the converse of Pythagorean theorem. And you can see that standard 11, topic 4, I can use the converse of Pythagorean theorem to determine if a triangle is acute, right, or obtuse. All right, so since we'll be focusing a little bit on the Pythagorean theorem, we've got an opener for you. So what I'd like you to do is look at the student work here. All right, pause the video and see if you can find the mistake that was made. And it's actually going to be a key piece of what we're going to talk about today. All right, so hopefully when you looked at this, the one thing that we know for sure when we do the Pythagorean theorem, right, and the Pythagorean theorem is a squared plus b squared equals c squared, is that c always, all right, has to be the hypotenuse, right? Always, 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 always. And we know the hypotenuse is always, all right, the side across from the right angle here. So that had to be the side of 26. All right, so that was really the major mistake that they made, right? That C has to be the 26, right? And they put that in as B. All right, now, for the work that we're going to do today, we're always going to assume, all right, let's go down to our, all right, let's go down to the investigation here, all right? We're going to look at some relationships between the sides of a triangle, all right? And what we have to know is that we're going to do a squared plus b squared, and we're going to do c squared. Now, for the investigation, C always has to be the longest side of the triangle, the biggest side. All right? A and B are just the small and the medium one. All right? I just get in the habit of saying A is the small, B is the medium, C is the large, right? So I just put them in order every time I do these types of problems, even when I'm doing the Pythagorean theorem, and then I know for sure, all right, I get to C squared. So, all right, so what I'd like you to do now is go through and, all right, do A squared plus B squared, a squared plus b squared, all right, do c squared, and then see what type of relationship exists here. And you've got 5 different cases here, all right, that you need to go through here. So there's 2 more on page 16 there to flip over and do. Now, the one thing I will say as you go, all right, is that you might have to, like, when you look at a square root here, all right, you might want to, all right, convert that to a decimal so you know exactly what that length is. So 4 root 19 may not mean a lot to you. All right, you may not know how that fits with these particular values. All right, so you might want to convert that to a decimal so you can see, okay, is that the medium side, is that the large side, and then work from there. So go ahead and pause the video, do this investigation, flip it back on, and then we'll see how you did. All right, so let's kind of go through the problems here. So when you look at the work here, so 97 is definitely the longest side here. All right, so that's why it's my c squared. And you can see when I do a squared plus b squared, I get 9409. And when I do 97 squared, I get 9409. So a squared plus b squared equals c squared. And that makes sense, right, if it's a right triangle. But notice that relationship doesn't always exist. So if we go down to the second one here, all right, and notice 4 root 19, all right, is the longest side. So that's why it's c. All right, so once again, right, if you didn't know what that was, right, so just, put that into your calculator, right, and kind of get that decimal approximation. Oh, that's 17 point something. Definitely longer than 14 and 10, right, to make sure you know where it fits in, all right, your scheme here. Now, notice when I do a squared plus b squared and I do c squared this time, I get a different relationship, right? They're not equal to each other, all right? So 296 is less than 304. So it can't be a right triangle because we know for sure, right, the Pythagorean theorem says that if we have a right triangle, a squared plus b squared equals c squared. So right here we know this has to be a right triangle, right? Because it works. So the question is if it doesn't work, can we figure something else out? All right, so now we go to the next one here. So once again, 3 root 5 is my largest side here. All right, so that's why it's over here. And then once again, I get 40 when I do a squared plus b squared, but I get 45 over here. So I get a squared plus b squared is less than 45. All right, so let's flip over, all right, and look here. All right, so when we look at these two, all right, a squared plus b squared, 579.4. Notice this time, 23 squared is 529. Now, a squared plus b squared is greater than c squared. All right, and then once again, when I look here, a squared plus b squared equals c squared. So that's a right triangle. And we know that, right, from what you've done with the Pythagorean theorem. Now, if we look, right, my first example, this was a right triangle. My last example, it was a right triangle. All right? But notice these two. These were both obtuse triangles. All right? These were both obtuse triangles. So when I go back over here and look, all right, at my obtuse triangles, right, I can see that a squared plus b squared is less, all right, than c squared. All right? And then if we look, we had only one example of an acute triangle, which was this example, and a squared plus b squared is greater than c squared. And so what this really means is that we can still look at that relationship of a squared plus b squared and c squared, and it tells us what type of triangle we have. All right, so remember when we talk about right, obtuse, and acute, right, we normally have to have angle measures, right? And I talked about that earlier, right? Like in the prior lessons, right? Ooh, I only have side measures. How am I supposed to know if it really is the right triangle, right? How do I not know this is 89 degrees, or maybe it's 91 degrees, right? There's no angle measure. Well, this relationship allows me to determine if it is acute, right, or obtuse based on those side measures. So here's what we know, right? If a squared plus b squared equals c squared, we know it's a right triangle. All right? If a squared plus b squared is greater than c squared, we know we have an acute triangle. All right? And if a squared plus b squared is less than c squared, we know we have an obtuse triangle. All right? And that's really, all right, what we want to do. Now, like I said, I always try to put these in order. A is my smallest side, B is my medium side, and then C is my largest side, just so I can always make sure I have that relationship, all right, as it needs to be. But the important thing is C always has to be the longest side. All right, so that takes care of page 16. Let's flip to page 17. All right, and I'm skipping the chart at the top because that's really what we just did right here. Okay, so we're going to jump right into, all right, some example problems here. Now, once again, all right, we're just going to look and see, okay, are these acute, obtuse, or right triangles based on this relationship of a squared, b squared, and c squared? So once again, notice these are in order. They're not always in order from smallest, all right, to biggest. So you always have to check. Don't assume. All right, so in this, I'm going to just let this be A, I'm going to let this be B, and this is C. And so I literally just want to do, all right, A squared plus B squared. All right, and I'm going to put a little box here and with a question mark over it because that's what we're looking for, right? What's that relationship? And then here's C squared, 28 squared. All right, so I'm just going to go right on my calculator here. All right, so 20 squared plus 21 squared is 841. So that's 841. And we still trying to figure out what's that relationship, right? And then I'm going to do 28 squared, and that's 784. So there it is right there. Okay. Now what I can see is a squared plus b squared is greater than 784. All right, so then if I go back to what we just summarized, right, when a squared plus b squared is greater than c squared, that tells me we have an acute triangle. All right, so what this tells me is that we have an acute triangle right here. All right, and notice we know that, and we don't even have any angle measures. All right, let's do one more together. All right, let's look at number 2 here. Now, once again, all right, I have the square root here. I don't know. Do you know what 5 root 10 is? Do you have an approximation in your head, right? So let's go ahead and just look at that and see what that really is. So 15.8-ish. All right, so 15.8-ish. All right, so now what we can see is like, oh, this is my longest side right here. All right, so this has to be C. All right, so 22 is my longest side. So I'm going to go 15 squared plus 5 root 10 squared. And then once again, we're trying to figure out this relationship here to 22 squared. All right, now, if I do this on my calculator, and I'm going to come back and talk about how to do this if you do it without a calculator and show you how to do that in just a moment. So we have 15 squared plus 5 root 10. And notice I'm putting that all, let me delete that there. I'm going to put that all in parentheses, all right, like that, and then square it like that. Because I want to square that whole number, so 5 times root 10. And that gives me 475. And once again, we're looking for that relationship, all right, and then let's see what we get when we get 22 squared. 484. All right, so that's 484. So now it's less than, a squared plus b squared is less than c squared. So that tells us we have an obtuse triangle, okay? All right, so let me talk about this if you're doing this by hand, right? So if I square this, I square the 5 and I square root 10. All right, so I'm just going to show you how to do this real quick by hand. So if I do that squared, I have to apply that square to both things here. So this would be 5 squared times the square root of 10 squared. And then 5 squared is 25. Now, when I square a square root, that undoes each other, right? Those are opposite operations. So this is 25 times 10, and then that would be 250. So if you're doing that by hand, all right, you can do that by hand. Just make sure you're good on that relationship. All right, so there you go. You get to finish the rest of your work here on page 17. All right, and that's it. All right, so 4 more problems, and I will see you guys next time.